We solve some numerical of gradient, divergence and curl. Here is a problem. If a equals to x square zi minus 2y cube z square j plus x y square zk, find del dot a at the point 1, minus 1 and 1. So we have to find divergence of vector a. That means del dot a. Put the value of del x of I plus del y of j plus del z k of k. Dot product of value of x a, that means x square z I minus 2y cube z square j plus x y square z k. So now for dot product, we know that I dot I equals to 1, j dot j equals to 1 and k dot k equals to 1. So the solution is del x of x square z plus del y of minus of 2y cube z square plus del z of x y square z. So after differentiating this, first term differentiate with respect to is x when z is a constant. That means 2xz plus minus differentiate y when z is a constant. That means 2 multiply 3 6 y square z square plus last term is differentiation with respect to z. That means x y square. So as the question is find the divergence of vector a at the point 1, minus 1 1, that means value of x is 1, y is minus 1 and z is 1. So now put the value of x y z in this equation. So 2 value of x is 1, z is 1, minus 6 value of y is minus 1, so minus 1 square, value of z is 1, so value of z is 1, so z square, x is 1, y is minus 1 square. So ultimately the answer is 2 minus 6 plus 1. So the answer is minus 3. Second numerical is given phi. Obviously phi is a scalar function that is equals to 2x cube y square z to the power 4, and find del dot del phi. That means divergence of grad phi. So we have to find first divergence, then but taking gradient of that, so we get the answer. So del phi, again put the value of del x of I, del y of j plus del z of k, and put the value of I 2x cube y square z to the power 4. Now as we do gradient of a vector, but we get a scalar quantity. We do gradient of a scalar, but we get a vector quantity. That means del x of 2x cube y square z to the power 4 I, del y of 2x cube y square z to the power 4 j, del z of 2x cube y square z to the power 4 k. Now again differentiate each term with respect to x, y and z. So differentiate this with respect to x, that means 6 x square y square z to the power 4 of I. Same differentiate it with respect to y, so 4 x cube y z to the power 4 j, plus with respect to z, that means 8 x cube y square z cube k. But as the question is del dot del phi, that means taking divergence of del phi. So del dot del phi, again del x of I, del y of j, del z of k, and obviously value of del phi, that is a vector quantity after doing the gradient. 6x square y square z to the power 4 I, 4x cube y z to the power 4 j plus 8x cube y square z cube k. Again, dot product of these two vector, that means del x of 6x square y square z to the power 4 plus del y of 4x cube y z to the power 4 plus del z of 8x cube y square z cube. Now differentiate each term. First differentiate with respect to x, that means 12x y square z to the power 4 plus differentiate it with respect to y, so 4x cube z to the power 4, differentiate it with respect to z, that means 3 multiply 8, 24 x cube y square z square. So this is the answer of del dot del phi. Third numerical related to the curl. If a equals to xz cube I minus 2x square yz plus 2yz to the power 4k, find del cross a, that means curl of a at the point 1, -1, 1. So write del cross a in determinant expression, that means first row is ijk, second row del x, del y, del z. Third row is the coefficient of ijk with sign, that means xz cube minus of 2x square yz 2yz to the power 4. Now solve this expression using determinant, that means I cross multiplication of this term del y 2yz to the power 4 minus del z of minus 2x square yz plus j of del z of x z cube minus del x of 2yz to the power 4, 2yz to the power 4 plus k of del x of minus 2x square yz minus del y of x z cube. Now differentiate each part. So with respect to y, that means 2z to the power 4 minus and minus a plus. Differentiate it with respect to z, that means 2x square y plus j of, differentiate it with respect to z, that means 3x z square minus with respect to x, so this is actually equals to 0 plus k, again with respect to x, so minus of 4x y z minus with respect to y, that means it is also 0. So ultimately the solution is 2z to the power 4 plus 2x square y plus j 3x z square minus plus minus minus k 4x y z. Now as per question, the value of x is 1, y is -1, z is 1. So put the value of x, y, z in this expression. So 2 1 to the power 4 plus 2 1 square minus 1 plus j of 3 multiply 1 1 square minus of k of 4 1 minus 1 1. So this is actually equals to 0, so there is no item for this case 3j and for this plus minus minus, sorry, minus minus plus 4k. So this is the answer of curl of a vector A given in the question. Fourth problem is, if the vector A is x square yi minus 2x zj plus 2yzk, find del cross A, that means curl of A. First we have to find this term, that means del cross A. So only determinant of this part ijk del x del y del z. So x square y minus 2xz 2yz. So after solving this determinant, I del y of 2yz minus del z of minus of 2xz. Now plus j, so multiply these two, del z of x square y minus of del x of 2yz plus k del x of minus 2xz minus del y of x square y. Now I can differentiate it. So 2z minus plus of 2x of I plus, there is no z term, so this is equals to 0. There is no x term, so this is also equals to 0. That means there is no j term, it is 0. For k, minus of 2z minus x square, this is actually answer. Now answer of this first part. Now taking curl of del cross A, so again we have to determine, we have to solve the determinant I j k del x del y del z, and third row contain value of I, that is 2z plus 2x, value of j is 0, value of k is minus of x square minus 2z. So solve this determinant I cross multiplication, so del y of minus of x square minus 2z, and this multiplication is 0, plus j del z of 2z plus 2x minus of del x of minus x square minus 2z, plus k of, again this multiplication is 0, minus del y of 2z plus 2x. So differentiate this term, there is no y term, so this is 0, so there is no I term, there is no y term, so this is equals to 0, so overall term is 0. For z, the answer is, here the answer is as differentiated with respect to z, so that is 2 minus, differentiation of this is minus 2x, so minus plus 2x, and that is equals to 0. For k, there is no y term, so this term is also equals to 0, so there is also no kth term, so the answer is 2 plus 2x j. So in the next video we'll continue this part and we solve another some problem. Thank you.